Hello everyone. Why is it easy to kick a football but difficult to move a large rock? Why does a loaded truck take more effort to stop than an empty one? The answer to all these questions lies in one important physical quantity, Massachusetts. Today, we will understand what mass is, its definition, units, properties, relation with inertia, and real-life examples. Let's begin. Introduction to mass. Mass is one of the most basic and fundamental quantities in physics. Every object around us, whether big or small, light or heavy, has mass. Mass helps us understand how much matter an object contains and how it behaves when forces act on it. Without understanding mass, concepts like force, inertia, momentum, and energy cannot be fully explained. Definition of mass. Mass is defined as the amount of matter present in a body. In simple words, mass tells us how much substance an object is made of, how difficult it is to change the motion of an object. Mass remains the same everywhere, on Earth, on the Moon, or in space. SI unit of mass. The SI unit of mass is the kilogram, kg. Other commonly used units include gram, g, milligram, mg, ton, 1,000 kilograms. In scientific calculations and physics problems, mass is always expressed in kilograms. Nature of mass, scalar quantity. Mass is a scalar quantity, which means it has only magnitude and no direction. For example, a body has a mass of 5 kilograms. This statement gives only the amount of matter, not any direction. Because mass has no direction, it is easier to measure and use in calculations. Mass and inertia. Mass is a direct measure of inertia. Backhand index pointing right, greater the mass, greater is the inertia. This means a heavy object resists changes in motion more than a light object. Example: it is easy to stop a moving bicycle, it is difficult to stop a moving truck. The truck has more mass, so it has more inertia. Mass and weight. Mass and weight are often confused, but they are different. Mass is the amount of matter in an object. Weight is the force of gravity acting on that mass. Mass remains constant, measured in kg. Weight changes with gravity, measured in Newton. N. For example, your mass is the same on Earth and the Moon, but your weight is less on the Moon. Types of mass. Inertial mass. Inertial mass measures how much an object resists a change in motion when a force is applied. Gravitational mass. Gravitational mass determines how strongly an object attracts or is attracted by gravity. In everyday physics, both types of mass are considered equal. Methods of measuring mass. Mass is measured using beam balance, digital balance, spring balance, indirectly through weight. Unlike weight, mass does not depend on gravity, so a balance gives accurate mass everywhere. Importance and applications of mass. Mass plays a crucial role in physics and daily life. Used in calculating force, momentum, and energy. Important in engineering and construction. Used in medicine for correct dosage. Essential in transportation and manufacturing industries. Mass helps scientists understand how objects respond to forces. Conclusion. To summarize, mass is the amount of matter present in an object. It is a scalar quantity, measured in kilograms, and remains constant everywhere. Mass is closely related to inertia and is a fundamental concept for understanding motion and forces in physics. Call to action: if this video helped you understand mass clearly, like the video, share it with your friends, and subscribe to the channel for more simple and powerful physics explanations. See you in the next lecture. Keep learning. 火箭